Okay, so precalc, this is your second half of the chapter review for your test on Thursday. Again, it's a good idea if you want a full review to watch both videos. So the first problem here, and I know they're a little small, so I'll try to rewrite them for you. We're going to evaluate this function, g of x equals 3, greatest integer of x minus 2 plus 5. And we have four different values to do. So we'll start with a. G of negative 2.7. So what we're going to do is we're going to plug negative 2.7 in for x. So negative 2.7 minus 2 plus 5. And we're going to simplify what's inside. So negative 2.7 minus 2 is negative 4.7. And now to take this greatest integer function, you're looking for the greatest integer less than or equal to negative 4.7. And the negative numbers work kind of weird. The answer to this solution right here, this greatest integer, is actually negative 5. That is the greatest integer less than or equal to negative 4. So then we will multiply by negative 5. So negative 15 plus 5 is negative 10. And there's the first one. B, g of negative 1 equals 3. Greatest integer of negative 1 minus 2 plus 5. This is 3. Greatest integer of negative 3 plus 5. Scroll down here. So the greatest integer less than or equal to negative 3 is negative 3 because it's an integer itself. And that's negative 9 plus 5. Negative 9 plus 5 is negative 4. There we go. Alright, then we'll do C. We won't do D, so we're gonna skip D. We'll just do C. C is I'm sorry, we're gonna do D, we're gonna skip C. Skip C. I apologize. So D. G of 14.5 is 3 times the greatest integer of 14.5 minus 2 plus 5. And if we take this, this is 3 times the greatest integer of 12.5. We're looking for the greatest integer less than or equal to 12.5. That would be 12. This is 36 plus 5. That's 41. And there's how you evaluate a greatest integer function. Okay? Alright, good. Next, problem 2. Piecewise function. Graph the function. So all we're going to do is use plot or point plotting. Okay? So for the top, f of x equals x squared plus 5. I'm going to make an x, y chart. Okay? I'm going to start with this value of 1 because it is the domain breaker. Notice it's equal to, so when I put the 1 here, I'm going to put a closed dot because on the graph this is going to be a closed circle. Well, when you put 1 into the function, you get 1 plus 5, which is 6. And now I have to go less than 1. So we're going to go to the next value, 0. When I plug in 0, I get 0 plus 5, which is 5. Negative 1, when I plug in negative 1, I get 1 plus 5, which is 6. So let's start with 3 points. Let's graph them and see what we get. So I'll use red for this part. So we have 1, 6, 0, 5, negative 1, 6. And you notice this is going to be a parabola. Alright, it's an x squared. Right, it's a parabola. And notice we start here and kind of go through this point back up. So I bet you it's going to keep going up. Let's check one more point though. Negative 2, right? We got to keep going less than 1, so negative 2. Negative 2 is, negative 2 squared is 4. 4 plus 5 is 9. Negative 2, 9. Negative 2, 9. Yes. And there's the graph starting at the first point and going through the other ones and continuing up. So there's the left half of the graph when x is less than or equal to 1. And again, notice it's a solid dot. And now I'll do the right half. F of x equals negative x squared plus 4x plus 3. And now when I make this xy table, again I'm going to start with 1, but it's not equal to, so it's going to be an open circle. So when I plug in 1, I get negative 1 plus 4 is 3. 3 plus 3 is 6. Now I got to go greater than 1, so try 2. That's negative 4 plus 8 is positive 4 plus 3 is 7. Now I got to try 3. I get negative 9 plus 12 is 3 plus 3 is 6. So that's 3 points. So let me graph those. 1, 6. Now notice this open circle I'd be putting on this closed circle. Closed wins. Closed wins. So leave that alone. So it stays closed. And now we go 2, 7, which is up here, and 3, 6, which is over here. And again, you have this idea of it being a parabola again, x squared. The negative out in front actually means it's going to go downward. So you'll kind of see if we start at this far left blue point and we go up, and it's going to go down, but we'll just double check with one more point. Let's try 4. You get negative 16 plus 16 is 0 plus 3 is 3. Negative 4, positive 4, 3. And connect those with the dots and you're good to go. And there's the picture. One parabola going to the left, one going to the right. So just plot points, don't make a mistake, graph what you get, and when you have an idea, okay, when you have an idea of what it looks like, you can stop plotting points and go to the next part of the function. Okay, piecewise function, good. 3, create an equation for the graph. So here we have this graph, and if you can't see, I'll put some points on here. This is the point 0, 1. This point right here is the point 1, 0. Okay? So we have to identify what kind of parent function this is. The parent function for this graph is the square root. So now what is happening? Well, our transformations are, I see got reflected over the x-axis. Reflect over x-axis. Okay? Vertical reflection. And once it reflected, so let's draw that real fast. So we're going to draw that in red. Reflect over the x-axis. So here's the parent function. 0, 0, 1, 1, 4, 2. When it reflects over the x-axis, it then comes down here to 1, negative 1, and 4, negative 2. And now the question is, well, how do I get this red one up to this solid one? Well, it's a shift up 2. Up 1. Shift up 1. So how do we write this, right? Because if we shift it up 1, we're going to be on that line, and that's good, right? We shift up 1, this point goes up here, this point goes here, this point goes there, and we have the line that they gave us. So we're ready to create the equation. How do I create the equation? Well, I have to know what these two transformations mean. A reflection over the x-axis means a negative out in front of the function, vertical reflection. A shift up 1 means plus 1 on the outside. So the only thing inside the square roots is the x. But now we add 1. And that would give us a reflection over the x-axis and a shift up 1, which is the equation of that graph. Okay. Next, we're going to graph. Here's the function. I know it's small. I'll rewrite it for you. G of x equals 2/3 x squared plus 4. We're going to identify the parent function. We're going to graph it. Then we're going to describe the transformations. And then we're going to graph the function we're given. So first thing is the parent function. Parent function is x squared. Over here, I'll graph it. 0, 0, 1, 1, negative 1, 1, and it's a parabola. So we get a couple things here. We have a 2/3 and we have a plus 4. That 2/3 is going to be a stretch or a shrink. It is outside of the function. So we have a vertical something or other, because it's outside. C equals 2/3, which is less than 1. If your value on the outside is less than 1, it goes with what you think it should. It shrinks. This graph is going to shrink vertically. So it's going to get short and wide. So instead of going up 1 each time, all you're going to do is go up 2/3 each time. So you might want to draw that. I'm going to draw it in blue. So instead of going up over 1 and up 1, we're now going to go over 1 and up 2/3. Left 1 and up 2/3. So there's my new graph. Just gets a little wider. I'm not trying to be perfect. Just show me what you know. Okay? And then the other thing is this +4. This +4 is a shift. It's outside the function. We go in the same direction vertically up 4. So I'm going to take the blue graph and move everything 1, 2, 3, 4 up. 1, 2, 3, 4 up. And 4 up. And there's your graph of this parabola. And you can see it just got a smidge wider. I mean, 2/3 is really close to 1. So it's just a smidge wider. And there you go. Handle reflections and these non-rigid transformations first, and then shift it second. All right, good. 5. Composition of functions. We're going to do both compositions and find the domain of each one. All right. So we'll start with f. I'm sorry, I'll copy them down in case you can't see them. So f of x is x squared plus 1. G of x is the square root of x. So let's start with, we'll do it in red, f of g of x. That is f of the square root of x. That means we put the square root of x wherever I see x in f. The square root of x squared plus 1. And that'll simplify to x plus 1. And now it's the domain. What is the domain of the inside function? The inside function was the square root of x. What's inside the square root must be greater than or equal to 0. You're done. 0 to infinity. So those are the x values you can start with. You can't even start with the negative ones. And now, the domain of the overall, x plus 1, there's no issues here. All real numbers. But because you can only start with the positive numbers and 0, you can't use all real numbers. You have to use just the positive numbers and 0. So there's your domain. 0 to infinity. Even though the end result has no issues, originally you couldn't use the negative numbers. Okay, and now let's try g of f of x. That would be the g of x squared plus 1. So we're going to replace x in g with x squared plus 1. So that's the square root of x squared plus 1. Some people might think that this square root will cancel with the squared. It will not because of the plus 1. So this is done. Okay. So now we must check the domain. Okay. First, the domain of the inside, x squared plus 1. This has no issues. It's a parabola. All real numbers. And now the domain of the outer guy, the square root of x squared plus 1. And there's an issue here, right? We have a square root. What's inside the square root must be greater than or equal to 0. So we need to find the x values to create our intervals to test. So what I'm going to do is I'm going to set this equal to 0 and solve. Subtract 1. Take the square root, and here we go. Square root of a negative number. This is imaginary. From your Algebra 2 days. Because this is imaginary, what this is saying is that there are no x values that are outside the domain. No x values outside the domain. So this domain is also all real numbers. If you think about it, if you plug any number in for x, you're going to square it and it'll become positive. So this will always be positive forever. Okay? So think about it. But here's the algebra behind it. Because you get imaginary solutions, there's no domain issues. So because both domains are all real numbers, That's your domain. All real numbers. With the domain inside function first, then the overall result second. Okay, and the last problem here. Look at number 6. We're going to find the inverse of this function, and this function is f of x equals 2x minus 3. We're going to find it algebraically and then graph them together. Well, the first thing I want to do is graph this because I want to see if it passes the vertical line test. So to graph it, you can either do it like a line if you know what it is, or you could do xy chart. I'll plug in 0. When you plug in 0, you get negative 3. 2 times 0 is 0. 0 minus 3 is negative 3. So there's 1 point, 0, negative 3. If we recognize that this is a line, which I hope you do, then all you need to do is the second point. Let's plug in 1. 1 times 2 is 2. 2 minus 3 is negative 1. And there's the second point. 1, negative 1. And here's my best job of drawing this line. I'm going to cheat and use the slope. Sorry. Only because I can't make straight lines very well in here. Oof. There. Okay, good. So this will pass the horizontal line test. I'll use this orange. Okay. So if I drew a horizontal line, it only touches once, which means that this function is 1, 2, 1. Each y goes to 1x. Remember this. Okay? I'm putting it on here for a reason. Alright. So now let's go ahead and find the inverse. To find the inverse, we're going to replace f of x with y. We're going to switch x and y. And we're going to solve for y by adding 3 to both sides. X plus 3 equals 2y. Divide by 2. And we get x plus 3 over 2 equals y. And we'll finish it up by putting f inverse in place of y. X plus 3 over 2. There's your inverse function. To graph this, okay, you can create an xy chart, or you can use this relationship. The x's and y's switch. So for this graph right here, we take these x's and y's from the original function and switch them. Negative 3, 0, negative 1, 1. Negative 3, 0, negative 1, 1. And there we go. And it should be a reflection over this line. I'll try to draw it in purple. The line y equals x. So if you graph this line, y equals x, that's this line, y equals x, you should see a reflection. And again, I can't draw straight lines, I apologize, but there's a reflection there. Now the last thing, I know I'm running late, the last thing I want to do is I want to verify that these two are inverses. Okay, we'll do that right here. So the original function, f of x was 2x minus 3. The inverse function that we got is inverse function is x plus 3 over 2. Let's verify. Let's do the compositions. F inverse of x. That is f of x plus 3 over 2. That means plug that into the function f2 times x plus 3 over 2 minus 3. The 2's cancel. X plus 3 minus 3. The 3's cancel. And there is x, which is what I want. That is one of the checks. The second check is the other composition. F inverse of 2x minus 3. That is 2x minus 3 plus 3 all over 2. Plugging it into f inverse. Well, up here the 3's cancel, and that's 2x over 2, and then the 2's cancel, and there's x. And that's exactly what wants to happen when you're verifying if two functions are inverses. Okay? Hope this helps. Study the whole chapter, come in confidently, and do well. Alright, thanks for watching.